Lastly, for the binomial theorem, here I give the computation of the characteristic function and also the the generating function, the probability generating function. And by definition, this is, if you remember, the expected value of the function e to the power j omega x. Okay, and we compute it by multiplying the function e to the power j omega k by the PMF here, right? Now here you see this is e to the power j omega to the power k. So I'm going to merge it with this term to write p times e to the power j omega to the power k. Okay. So I have from sum from 0 to n choose k, something to power k, something to power n minus k. So recall the binomial theorem. I have this thing plus this thing raised to power n. Okay, this is just directly from binomial theorem. Okay, p times e to the power j omega plus 1 minus p to the power n. Now, if you remember, the generating function was defined as e to the power, the expected value of z to the power x. And if you recognize the correspondence here, well, this would be defined for x being in the set 0, 1, 2, etc., which is the case here. Well, we have it up to n, but it doesn't matter. The thing is, in such a scenario, you can obtain the characteristic function by replacing e to the power j omega with a z in the characteristic function. Okay, so you have p times z plus 1 minus p to the power n. But if you want, of course, you can compute this yourself, and you should see that you obtain the same result. So this concludes the discussion of binomial distribution. We have seen what it means, the number of successes, for instance, the number of heads in a sequence of 10, let's say, coin tosses, okay, or the number of sixes you get on 20 throws of a die, etc. Or let's say the distribution of the number of boys in a family with 6 children, let's say. Okay, so these are all quantities that can be modeled using a binomial distribution. We have observed the expected value, the second moment, the variance, the characteristic function, and the probability generating function. And let me also point out to you, you can also compute the moments using the characteristic function or the generating function using the moment theorems.